Yes. Yeah. Good afternoon. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yes, screen is visible and your voice is clear and loud.
Fine. Yes. So
Yes.
in the yesterday session, just I was briefing you about what is big data and why Hadoop, drawbacks with the current databases, right? So huge volumes of data in petabytes of data is getting generated. So to handle that huge data and to process that huge data, we have got big data tools like Hadoop and PySpark. So here, Hadoop is meant for mainly for two things. Hadoop is meant for two things, right? Yes. Hadoop is for two things. For storage and for processing. For storage and processing. So any technology performs either storage or processing, but Hadoop performs both storing and processing. But for storing data, it doesn't use any database because there are some drawbacks with the databases. So despite with drawbacks with databases, it's going with a kind of file system called Hadoop distributed file system. What is it? Hadoop distributed, yes, file system. And for processing, right, it is going with an execution model called MapReduce. It's going with an execution processing model called as MapReduce. And currently we are using Spark processing, right? So Hadoop is for both storage and processing. For storage, it uses HDFS, and for processing, it uses MapReduce. So Hadoop is for batch applications. Hadoop is for batch processing. So Hadoop is meant for batch applications. Hadoop is meant for batch applications. Most of the bank and financial applications are batch applications. So there are two types of applications I was saying, right? There are two types of applications. Online applications, user interactive applications. Here user use the input, right? Example like making an online transaction. Batch applications, user non-interactive applications. Here user is nowhere required. PNR status, generating credit card statements for millions of customers, right? Yes. Drawbacks with the current databases, right? Drawbacks with the current databases. Very limited storage you see in databases like GBs or TBs. No parallel processing in most of the databases. If volume increases, speed decreases, right? So if you see these queries, right? Query to query, as this volume increasing, speed decreases. Even if complexity increases, speed decreases, right? Select sum of amount from sales one, average amount from sales one. So query to query, yes, the complexity increasing, speed decreases. And major drawback with the databases, they can handle only structured data. They cannot handle unstructured or semi-structured data. Just 1 second. can handle only structured data. Yes. Before I go with advantages of Hadoop, right? Before I go with advantages of Hadoop, you need to know something, right, about this Hadoop. Yes. Hadoop architecture. Hadoop doesn't follow client server architecture. It won't follow client server architecture. It follows, Hadoop follows master slave architecture. It follows master slave architecture. Hadoop doesn't follow client server. Hadoop follows master slave architecture, single master and multiple slaves. Yes. Hadoop follows master slave architecture, right? Single master and multiple slaves. Single master and multiple slaves. So why how parallel processing? Hadoop performs parallel processing, right? Yes. Observe this. Yes. Single master and multiple slaves. Single master and multiple slaves. Master. These are slaves. S1, S2, S3, so on, Sn. Single master and multiple slaves. So group of CPUs connected in a network. And that one will be the master, the other will be the slaves. This we call it like a cluster. Yes. So yes. So Hadoop follows master slave architecture, right? What do you mean by a Hadoop cluster? What do you mean by Hadoop cluster? Means group of nodes. Group of nodes. Nodes means CPUs. It's a group of CPUs connected in a network. Connected in a network, right? Yes. Group of nodes. There are two types of nodes here. There are two types of nodes. There are two types of nodes. First one, master node. Master node, we call it as like name node. Master node, name node. We see name. And secondly, like slave node. Slave node, and there is nothing but data node. Master node, name node, slave node, or data node, right? So what are the master node responsibilities, slave node responsibilities? So here there are two types of nodes, master and slave. It follows master slave architecture. It won't follow client server architecture. Just observe this single master and multiple slaves. In Hadoop, data is stored in the form of files f1.txt. Assume the file size is 2 TB. Assume that file size is 2 TB, and each system slave 1 TB size. 1 TB, hard disk capacity 1 TB, 1 TB, 1 TB. Assume that each system has got 1 TB, right? 1 TB, 1 TB, and 1 TB. This file f1.txt cannot be loaded into any of the systems, right? So it will be splitted into smaller parts. Right? Each part is going to be stored across multiple systems. Each part is going to be stored across multiple. Two advantages you are going to see here. So everything happens in the automated fashion. We no need to perform anything. So here f1.txt, it will split it automatically and will be stored across the systems. So here, two advantages. One is distributed storage, you can see distributed storage and parallel processing. Distributed storage, the means data is got stored across multiple systems and is processed by multiple systems parallelly. Data is distributed across multiple systems and data is processed by multiple systems parallelly. Yes. Data stored across the slaves and data processed by multiple slaves parallel. Yes. Distribute, see here, parallel processing is going to happen, distributed storage and a parallel processing. So data is stored across multiple systems and are executed parallelly. That's why very high speed processing you are going to see for within this Hadoop. So this master is going to assign the master node is going to assign task T1 task to this, T2 task, T3, T4. T1, T2, T3, and T4 tasks. Yes. Going to assign multiple tasks. Yes. Master node responsibilities. Observe this, master node responsibilities. Master node responsibilities, right? Yes. Task assignment, load balancing, group of nodes CPUs connected in a network. Master node responsibilities like task assignment, load balancing, fault tolerance, right? I'll just say what is it, and health monitoring, master node responsibilities. So who assigns tasks to the slave systems? Master. Means the task should be equally assigned to all the slaves. A particular slave should not be burdened, so task has to be assigned equally to all the slaves. Load balancing. Fault tolerance. Fault tolerance means right. Observe. Observe this diagram. Fault tolerance means if 4 tasks T1, T2, T3, T4, 4 tasks assigned to the 4 slave systems. 4 tasks are executed by the 4 systems parallelly. Suddenly, if any system goes down, the task of it has to be assigned to any of the other slave, right? This process we call it as fault tolerance mechanism. Who takes care about it? Master node. Who assigns? If any system fails, the task of it should be assigned to the other slave. Who assigns? Master node. Health monitoring. Before assigning a task to a particular system or a slave, so in it will already the master will have the health status about all each and every slave. So the health monitoring also, right? So these are the, so if you observe this diagram, right? So generally the file divided into parts and stored across multiple systems and processed by multiple systems. So these are slave nodes. This we call it like slave nodes or data nodes. Slave nodes are data nodes. Data nodes means data is stored within the slave systems, data is processed within the slave systems. Data storage happening within the slaves, data processing is happening within the slaves. That's why we call data nodes. So if storage is done by the slaves, processing is done by the slaves, what master node is doing, right? Means like assigning task, load balancing. If any in the failure of any slave, then the task has to be assigned to other slave, and health monitoring, right? Yes. Yes. Next, slave node responsibilities. Slave node responsibilities. Slave node responsibilities means two responsibilities: storing the data and processing the data. Storing data and processing the data. Slave node responsibilities. Yes. Understand this? Yes. Slave node and master node. So Hadoop follows master slave architecture. It doesn't follow client server, single master and multiple slaves. So more on this I'll be discussing in the Hadoop architecture, storage architecture and processing architecture, right? Yes. So cluster means group of CPUs connected in a network. And advantages of Hadoop, right? Unlimited data storage. Unlimited data storage is possible. Very high speed processing. Very high speed processing because of parallel processing. Unlimited data storage. Unlimited data storage is possible because of a feature. Unlimited data storage is possible because of a feature, right? Horizontally unlimited scalability. Horizontally, right? Horizontally unlimited scalability. Understand this?
What does that mean, Vijay? Horizontally unlimited scale.
Yeah, I'm coming to that. So unlimited data storage is possible in Hadoop means whatever the data, whether it is in TBs, petabytes or higher than that, it can accommodate, right? What is this horizontally unlimited scalability means? Horizontally unlimited number of slaves can be added. For example, if you are running a business, okay, you've got some slave systems. You're running a small business with less number of slaves, S1, S2, so on, right? SN. So with the 10 systems. Tomorrow your business has increased, your branches are increased, your data is increased, customers are increased, right? Customers are increased means data is increased. So you cannot go with the same number of slaves. So if customer branches have increased, customers are increased, data is increased, you will be increasing the slave systems horizontally from 10 to you went to 100. Means horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Still if data is if customers are increasing, if still branches are increasing, if data is increasing, right, still you will be keep on increasing, right? Yes, this is what horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Because of this, right? Unlimited data storage is possible. Yes. So yes, for example, here, if customers are increased by 100 times, custom data is increased by 1,000 times. You cannot go with the same number of slaves, right? We need to keep on increasing the slaves to accommodate the data, right? And very high speed processing, right? Because of parallel processing, very high speed processing because of parallel processing. So how this parallel processing, I'll say one labor example. Very high speed because of parallel processing. Observe this. Okay. For example, if you talk about non-parallel and parallel, non-parallel and parallel. Non-parallel and parallel, right? In the case of non-parallel, right? For example, take one person preparing one item takes 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items, 100 minutes it takes. So same one person preparing 1000 items takes 1000 minutes. This is non-parallel. Only one person will be working here. But in the case of parallel, one item takes 1 minute, 10 items takes 1 minute, 100 items also takes 1 minute. Parallel processing. Hence here 10 persons preparing 10 items take 1 minute. 100 persons preparing 100 items takes 1 minute. Means parallel processing. 100 persons preparing 100 items parallelly taking 1 minute. Here also, here I said persons in our context, right? It's a system, slaves. So here, very high speed processing because of parallel processing. Okay. Can handle all varieties of data. Can handle all varieties of data. So like structured data, semi-structured data, and unstructured data. Hadoop can handle all varieties of data, structured, and the biggest challenge is handling and processing the unstructured or semi-structured kind of data, right? Where databases cannot handle that semi-structured or unstructured data. Open source. Hadoop is an open source, no licensing required. We take from Apache Mirror's website, right? We take that software, right? Hadoop software, and we'll be installing, right? So it's an open source, no licensing required. So cost cutting, right? So means is it an advantage? If Hadoop is an open source, no licensing required means is it an advantage? Means if you're establishing a company, assume that you just establishing a software company, right? So where for the company require both hardware with, for example, with 10 crores, just assume that a small company with 10 crores, you require both hardware and software. Hardware and software. You are spending 4 crores on hardware, you are spending 6 crores on software. Means in each and every system, the licensed software has to be installed, right? So that's if Hadoop is an open source, no licensing required. It's a kind of cost cutting, right? So it's a kind of advantage. Open source, no licensing required. Commodity hardware. Hadoop, the softwares, Hadoop can run on any hardware. And it doesn't mean that it should have very highly configured systems. No, it can commodity hardware. It can run on any hardware configuration, right? The main advantages of Hadoop: unlimited data storage and very high speed processing, right? To just say about its very high speed processing. So you can see Yahoo has conducted a test to check the speed of various databases, right? The test has taken a table of 100 TB, sorting based on 16 columns. So what is the time taken by different databases? Oracle has taken 3.5 days, MySQL has taken 6 days, and Teradata has taken 4.5 hours, Netezza 3 hours. Hadoop has taken days and hours, but Hadoop just 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes, right? So that is what motivation towards Hadoop and the speed of Hadoop as compared with the other technologies. Even Spark has got very high speed, right? Even that in-memory computation, right? Hadoop and Spark both that Hadoop is storing and processing, even PySpark, right? Very high speed processing in memory computation, right? If you are able to provide huge RAM capacities, right? Where Spark can run at a very high speed. So, okay, this is a very high speed processing. But even one more example, that unlimited data storage is possible. Why only in Hadoop? Why only this data store, high limited data storage is possible only in Hadoop? Why not in other databases? So I got a query. Why database like Oracle? So query, right? Why databases like Oracle doesn't support databases like Oracle doesn't support unlimited storage. Why only Hadoop can perform? Why databases like Oracle doesn't support unlimited storage? Means we talk about these databases, right? They have got some limitations. Even if we talk about this database like Oracle, these things, right? They can go with multiple slaves. So databases, talk about these databases, maximum limit on number of slaves. Max limit on number of slaves. Max limit on number of slaves. So databases, first like Oracle has got like 256. No, it's 256 slaves. Maximum Oracle can go with maximum 256 slaves. Nodes. MySQL can go with only MySQL can go maximum with 54 slaves. Maximum it can go with 54 slaves. And here MySQL Express, right, can go with maximum 256 CPUs. DB2 can go with maximum 256. And if you talk about SQL Server, it can also go with maximum 256. See, all these databases are used for OLTP, online transactional processing for day-to-day operations. So all these databases, right, there is a limitation. They can go only with 256 slaves. Beyond that, they are not supported. So if we talk, even if 256 slaves, if it is reaching 256 slaves, right, even the performance of the system will be degraded. For example, just like if I take an example, just like a mobile phone. In the mobile phone, for example, if you have got 64 GB internal storage, if all the 64 GB internal storage is filled, the performance of your phone will be degraded. It will go slowly. Sometimes it won't even start. The same way, if Oracle, if it has got 256 slaves, it has reached all the 256 slaves, then the performance of this will be degraded. Sometimes it won't even start. So databases, they have got this limitation. But if you go with specialized databases like Teradata, if you heard about like Teradata, can go with 512 systems, 512 slaves, 512 systems. Netija, right? Yes, can go with 512. Vertica can also go with 512. Teradata with 512, Netija with 512, Vertica also with 512 slaves, right? Yes. Okay. But currently, Teradata and Netija, right? Teradata going with 1024, right? Slaves. Netija also going with 1024 slaves. Even 1024 slaves doesn't mean that unlimited data storage is possible. No. Once they get filled, they cannot support data further, right? So all this, there is a limitation. Even if we talk about databases and specialized databases, there is a limitation on the number of slaves. Beyond that, they cannot support just like but there is no limit. There is no limit on the number of slaves. But there is no limit on the number of slaves that Hadoop can have. There is no limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves. It can go with unlimited number of slaves. There is no limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves, right? Yeah. Yahoo, when first time implemented, just observe this. Yahoo, when first time implemented Hadoop. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with. Currently, Yahoo going with 12,000 slaves. 12,000 systems, right? Facebook. When first time implemented. Yeah, Facebook when first time implemented Hadoop. When first time implemented Hadoop, went with 8,000 slaves. Currently, right? Currently, Facebook, right? Facebook going with 42,000 slaves. That is what, there is no limit on the number of slaves that Hadoop can have. Unlimited, horizontally unlimited scalability. There is no limit on the number of slaves. Yahoo, when first time implemented, went with 4,000. Later, currently, it is going with 12,000. Facebook, when first time implemented, Hadoop went with 8,000. Currently, Facebook going with 42,000, right? Not like 256 or 1,024, right? And like 4,000 or 8,000 or 42,000, unlimited number of slaves that Hadoop can. So Hadoop proven in the Hadoop proven in the market, storage point of view and processing point of view. The storage point of view, unlimited data storage, and processing point of view, very high speed as compared with that. So that's the reason, right? Today, like most of the projects are migrating towards this big data environment, Hadoop and Spark environment, where with huge data storage and huge data processing, right? Hadoop ecosystem components. Hadoop ecosystem, what I'm going to discuss, right? How about ecosystem components? Yes. So I'll be discussing, as part of this course, I'll be discussing storage and processing components. I'll be discussing storage and processing related components, storage and processing. For example, HDFS, Hadoop Distributed File System. HDFS meant for storage, is meant for storage. For huge data storage we go for HDFS. We doesn't use any database. MapReduce. MapReduce. It is meant for processing. So it is a parallel execution model. MapReduce is a parallel execution model, especially designed for parallel processing. And Apache Hive. We have got Apache Hive, right? Yes. It's a kind of data warehouse kind of environment. It is a data warehouse kind of environment in Hadoop framework. So here we use a language called HQL, which is similar to SQL. So almost 90% will be same. HQL, right? Similar to SQL. So here we'll make the data structured. Here we are going to make the data structured and create tables like internal and external tables and performing querying on that. And we have got many performance tuning mechanisms here in Hive, like partitioning, static partitioning, dynamic partitioning, multi-column partitioning, and also like indexing, right, and bucket. And also I'll be showing you how to work with varieties of data like XML data, working with XML, working with JSON data, working with URL weblog data, right? Yes. Apart from this, one more. Scoop, SQL plus Hadoop. SQL plus Hadoop. Generally, from where you get the data in HDFS, from where data you are going to get the data to HDFS from databases, right? From databases, you are going to pull the data into HDFS. So the scoop component does it. Importing and exporting operation from databases to Hadoop, from Hadoop to databases. Who imports and who exports? Scoop, SQL and Hadoop. First two characters of this SQL and last three characters of this forms scoop. It's for import or export operation, just for importing or export. And I'll be discussing about NoSQL database. NoSQL, right? Not only SQL. In SQL, right? Structured from first record to last record, same number of columns to be maintained. But in NoSQL, record to record, different number of fields can be maintained. My first record with 3 fields, second record with 5 fields, third record with 10 fields. A record to record, different number of fields. It's schema-less behavior, right? Schema-less behavior and random access. Yes, schema-less behavior and random access. Okay. Scoop for import export, NoSQL scheme. So I'll be discussing one NoSQL database like HBase. HBase is like a Hadoop database. So HBase is a kind of NoSQL database where we perform this schema-less behavior random access. Okay. Apart from this, so yarn, YARN, yet another resource negotiator. Yarn, yet another resource negotiator. From Hadoop 2 version onwards, we have got some architectural changes. So previously there were little drawbacks, everything were rectified. So the yarn architecture, yarn components, how the yarn processing is going to happen, everything I'll be discussing. Apart from this, like the zookeeper, right? Yes. The name itself saying zookeeper, it controls and coordinates all the other Hadoop components, right? And giving connections, controlling all the things taken care by zookeeper. And Kafka, Flume, Kafka, knowledge and Flume, Kafka, right? Flume Kafka, it's for streaming data, for streaming data which keeps on generating, data which keeps on incrementing, data which keeps on generating, and data which keeps on incrementing. Such data we call it as streaming data. Yes. blue mark Kafka. Yes. And apart from this, the important component Spark, PySpark. PySpark, right? Yes. In this PySpark, right? It's a very high today. This PySpark has got very huge boom, right? You can see in the market, very high speed processing in memory computation. Okay. So here also in PySpark, once PySpark 4, PySpark SQL. Just 1 second. So yes, PySpark, right? Very high speed processing in memory computation, where we will be discussing about Spark 4, Spark 4 programming, right? Here Spark SQL, right? Spark SQL. We will be discussing like Spark streaming, right? Yes. So everything will be discussed in brief with multiple examples, right? Working examples. So the only thing is, if you are attending the sessions regularly and if you're doing the practicals and if you're interacting during the sessions, right, it looks very simple. This looks very simple and easy to understand, right? If you're regular and if you are just doing the practicals, for example, if I today some practicals, if you do the day itself, the next session, next, if you are interacting, if you are responding in the session, right, you will be able to interact and respond. So that's what being regular to the sessions and practicing the practicals and asking queries and working with the tasks. So it looks very simple it looks, but for 3 weeks, if you're not doing any practicals, okay, it will be understandable. Everything statement by statement, I'll be explaining and I'll be showing you these things, right? It looks simple and easier. Yes. And in PySpark, right, we will be discussing very less coding. You see, not huge, very less coding. Already we have got many inbuilt functionalities for performing the operations. So if we talk about this PySpark, so just observe this PySpark. Need for PySpark session context. See that how much depth I'm going into this PySpark, right? PySpark session context, parallelize, broadcast variables, accumulators, PySpark RTD computations, persistence options, whether you want in memory or in disk or memory and disk, PySpark core computations, how this fault tolerance model, different ways of creating, increasing the number of partitions, grouping, segregation, single, multiple, process of grouping by key, reduce by key, various inbuilt actions and transformations. Inbuilt actions and transformations, one by one, I'll be discussing, right, with some examples. All this count by key, count by value, union, distincts. Here we don't need to write any code. Directly we have got inbuilt transformations available. Directly we will be applying it, right? And SQL data frames. Later we discuss about data frames, where data will be made into structured format. Data frames will be created in rows and columns, and data frame APIs like show, row class, column, select, collect, with column. So many built-in functionalities here also for data frames, where, filter, drop, order by group, join, union, UDF map, flat map for each sample, fill, pivot, all this. PySpark SQL functions, aggregate functions, window functions, date and timestamp, JSON functions, read and write. PySpark built-in functions. So when expr, lit, split, cat, translate, overlay, to timestamp, to date. months, explode, array, collection, map underscore keys, map underscore values, struct, row number, dense, percent, from JS1 to JS1, right? Okay, all this. And PySpark external sources, working with SQL statements, Hive integration, MySQL integration, CSV, working with CSV, working with JSON transformations, narrow and wide transformations, adding new columns, dropping columns, renaming, adding of rows, dropping rows, handling nulls, writing data back to external sources, creating tables from data frames, deployment, right? Local and cluster, right? And PySpark application stages and tasks, drivers and executor, building Spark applications, deploying Spark apps to cluster, performance tuning, PySpark streaming, integration with Kafka, and PySpark MLlib. And apart from this, Hadoop components, right? As I said, introduction, HDFS, Hadoop distributed file system, how the storage, and we have got different name node, data node, HDFS architecture, metadata management, replications, configuring, fault tolerance, yes, HDFS commands in brief, map reduce execution model, parallel processing, mapper phase, reducer phase, and how it is going to, what happens during this mapper and reducer, right? And scoop SQL plus Hadoop, importing data from database to HDFS, importing data and exporting data, right? Transformations during this import, filtering during this import, mergings during this import, and working with delimiters, groupings and aggregations during this import, incremental importing, examples and operations, defining scoop jobs, and yarn architecture, and how the yarn processing, yarn different components, and how this, and NoSQL database, as I said, NoSQL database, right? NoSQL database, what are the different NoSQL database, and one NoSQL database, HBase I'll be discussing in brief, I said, right? Yes. Yes. So here I'll be giving knowledge on one storage component, HDFS, and nearly like 3 processing components, MapReduce, Hive, and PySpark. These 3 are meant for processing, 3 processing components, and NoSQL, one NoSQL database, and one streaming component. So knowledge on this one streaming component, one NoSQL database. If possible, I'll give knowledge on this cache and one more NoSQL database, 3 processing components, 1 storage component, right? This is fully enough, right, for attending any big data interview. Right. So yes. So just the importance storage wise and processing wise, just I was saying, right, why only Hadoop can perform, and the speed of Hadoop as compared with other things, and storage wise and processing wise as compared with other things, master slave architecture. In brief, I'll be discussing about the architecture and why databases, drawbacks with the databases, and it's for batch applications, millions and trillions of records, we go, and user non-interactive applications, we go for Hadoop. Yes. So before I go with the practicals of this, I'll be just briefing you with Linux commands, right? That everything. First, before this Linux, just I'll be briefing you about the software, right? So I'll be providing you the VMware, right? Software. This I'll be forwarding to your Google Drives. Next, I'll be discussing about the Linux commands. Like before I go with the practical part of Hadoop. And people who wants, I said there are 2 types of packages available, with Python, without Python, right? People who wants with Python, right? They can go parallelly, they can learn Python parallelly, right, in weekdays. So I said, for Python, those who wants Python, right, there are multiple batches of Python, right? So on this, tomorrow there is a batch starting night, especially for the people, job holders, right, night 10 p.m. Tomorrow it's starting Monday, tomorrow night 10 p.m. You can see this in the chart, right? You got some contact details. You can just contact them. They provide you the link. So tomorrow night 10 p.m. right? Yes. But initially the demos 1 week demos will be at 10 p.m. Later it will be at 9 p.m. right? Yes. Okay. Fine. 10 p.m. right? If anyone a new batch running at 10. And
Vijay, you are going to take this session, right?
yes, be Python I'll be only discussing, right? And apart from if this is not suitable, there is one more Python batch on December 6th, means Wednesday, this coming Wednesday, right? At night 8 p.m. There is one more batch of Python, right? Night 8 p.m.
Yeah, we have to join with same link, no?
No. 1 second, I'll come back to it. Not same link. And if not possible in the evenings, if you've got mornings, right? Sorry, this is 8 morning 8 a.m. Morning 8 a.m. right? And December 12th, Tuesday, I think. There's one more at evening 8 p.m. So already multiple PySpark batches are going on, multiple big data batches are going on. So people from all those, they can attend, see night, these 3 batches next 1 week. So these things, you can take a snap and you can just call this online team. So they'll forward you the link. It means this Python, right? So big data. So Hadoop plus mainly PySpark, Linux included, right? It's the fee structure, right? It's 12K for this, all these 3, and Hadoop, and people who wants to have additionally like Python, right? Means in Python you'll be both core and advanced, both you'll be learning there, right? So it will be like 15K. So Hadoop plus PySpark and Linux.
Plus Python, Vijay.
Yes, Python, sorry, plus Python, right? Plus Python, it is 15K. People who are already paid for Python, right? Okay, just you can discuss with the online team. If you already some people who are already learning Python, right? You can just discuss with the online team for, okay, they'll provide some concession for you, right? We have already joined and who are doing Python currently, right? Learning Python with me. Okay, fine. Okay, here we are giving a Python like 50% discount applied on this Python course. Means when you are learning these things. So that's fine. You can talk about this, all this, right? With the online team. The contact details are provided. And if you see in the chart panel, the course content, everything is provided. And even Python also will be dealt in brief. I'll be discussing Python in brief. Nearly it takes 1.5 to 2 months discussion on Python, right? Because today Python directly or indirectly, if you see any high-end technology, need to have the knowledge on Python, right? And Python, where I'll be discussing procedural oriented with Python, object oriented with Python, scripting and modular programming with Python, right? Because thousands of models Python is providing towards big data, data science environment, right? So if you talk about in data, this analytics, like Python has got many modules, libraries like NumPy, CP, Pandas, PyTables, Matplotlib, CP, Scikit-learn. So I'll be discussing some of the important modules like NumPy module, numerical Python in brief, Matplotlib, plottings and visualization module in brief, Pandas module in brief, especially Pandas, right? Even for big data environment, right? Pandas is mainly right for big data environment. Pandas, NumPy, Matplotlib, another like the database, Python and database connections. Everything will be dealing. Sorry. So get enrolled, right? Get enrolled for this course. Everything will be discussed in brief. So that's why it's not. We are be spending like nearly like 12 weekends for this. Okay, for all this Hadoop PySpark and this. So you can see that the payment details and the other things right in the chart panel, and also to your mail IDs they'll be forwarding it. See in the chart, a big chart message is given, like yesterday's demo video and today's video also you'll be getting right to your mail ID. They'll forward that. And as I said, once you get enrolled, right, you'll be getting the videos every video you'll be getting to your Google Drive notes to your mail IDs. Yes. And WhatsApp group will be created, right, for technical discussions, doubts and queries, right? Fine. So all this, for all this, the videos will be provided for all this, right? Yes. Yeah. Fine. Any other queries, right? So from next week onwards, we'll be starting with that, right? I'll be starting with HDFS, Hadoop Distributed File System. The first component, right? HDFS. We need to understand about how this data storage is happening, how the file is getting stored in database tables. In Hadoop, we have got file, TXT files, right? Different types of files. So how data exactly is stored, how data is stored, and what happens if a cluster is a bigger cluster, if a cluster is smaller cluster, right? Yes. Fine. Any other queries, right? From next Saturday onwards, we'll be starting. So get enrolled. Next Saturday, the link will be changing, right? So you are supposed to get enrolled on this course to get that new link. The link will be forwarded to your mail IDs. The link will be forwarded to your mail IDs, right? You can check that. Otherwise, if you have not got the link, even after doing the payment, right, you can just contact the online team. Means if you're done, right, the link will be forwarded on next Friday. Saturday will be the class. Friday you'll be getting the link by Thursday or Friday, right? And one more thing, if some people, right, they'll be facing problem saying that they didn't get the link. Once you do the payment, right, don't forget to share the screenshot of your payment to the mail ID provided there, DURGASOFT online training at gmail.com. So it's okay. Any other queries from your side? So the sessions need to, I am expecting the sessions to be interactive. So you should keep on responding, right? So whenever you are doing with the practical part, compulsory you will be responding, right? Yes. You will be kept in unmuted status at any point during the session, right? You will be, if any query, you can ask then, right?
Hi Vijay,
Yeah.
Dhanush this side.
Yes.
Vijay, so you are giving all this knowledge, right? So with whatever the knowledge you are giving, so how many years of experience we can keep and
so a typical 4+ years person, how much knowledge if you have got, right? That much of knowledge I'm providing, right? So based on all this. So if you see the course content only, you can just understand, right? In brief, in depth, we'll be discussing, right?
Yeah, in depth we will be discussing, and I mean, so how many years of experience we can keep in our resume?
So if you're it's a new technology. If you're working in Hadoop environments, it's okay, you can keep. But if you are new to this technology, that means how much good technical knowledge you have got, how much confident you are, you can keep, right? You can go with the 5 years, 6 years. Right?
Okay.
But
okay, sure.
Yes, if you have got the command and the technical part, that depends upon you how good you are practicing. So definitely, right, the knowledge what you are going to gain, a typical 4+ years of experience person, how much knowledge he has, that much of knowledge you are going to get.
Okay, sure.
Fine. Okay. So only
and
only one thing, right, from my side. Okay.
Yeah.
So you should be regular to the sessions. Being regular to the sessions means you should interact and you should respond during the sessions, right? Means it's a data flow language. Spark is a data flow language, and some topics will be interrelated. And you need to complete the practicals. And if queries are there, you need to ask. I'll be giving time at the start of the session, right? You can ask that queries. And for that, I kept a WhatsApp group for technical discussion. If you got any error, You can just take a snap and keep it that and keep a debate in the WhatsApp, right, about that, and use that WhatsApp group for technical discussions. And until that, I'll be saying that if anyone no need to wait up to the next week, right? And during the week, if anybody got any errors or if anything to, even I'll be specifying some time for that error, right? I'll say please join the session, right? Especially if anyone facing any installations, other things, right? Fine. So it looks very simple and easy if you are doing the practical and if you are completing the day itself, or that this week practical, this week only you need to complete, right? Yes. I cannot keep on.
Vijay, one more, Vijay.
Yes.
Vijay, so if you are freshly learning this Hadoop and big data technology, so whatever you are teaching, so they will be asking about some projects, right? So previously, what have you been working on, like that? So for that, we need to have some projects, right?
So just
what about that?
I'll be providing you those things, right? And also I'll be
Yeah.
providing some resumes. I'll be providing and roles and responsibilities, what you did and how you did, right? Those I'll be providing, and some to keep in the resumes that I'll be forwarding you, right?
Okay. This is nearly close to 3 to 4 months of course, right, Vijay? So how long we will be you will be accessible to us? I mean, so whenever we get some doubts or something like that, so even after 6 months we can ping and ask you, right?
You can ask me. You will be, the WhatsApp will be there. Last 2020
Okay.
WhatsApp groups are also live, right?
Yeah, it will be live, but how long will you be available for us?
Yes. You can just ping me that. You have got my number, right, in the WhatsApp. You can just ask me.
Okay.
I'll be helping you.
Okay, anytime.
Yes.
Yeah, sure, Vijay. Thank you, Vijay. Thanks for all the information.
Okay. So from next Saturday onwards, we'll be starting at 4 p.m., right? So we'll meet on next Saturday. Fine. But with different link, get enrolled. You'll be getting the link to your mail IDs, right? Thank you all for your time. Thank you.